Hi, I'm Hassan, the lecturer here at the Institute of Medical Education, and today we're going to take a look at solutions to Section 3 of ACER's GAMSAT Pink Booklet, Practice Test 3, specifically Unit 23, questions 64 to 65. And in this unit, we're going to take a look at dental cements. Now, a lot of people forget that if you're going to be sitting the GAMSAT, it's not just to get into medicine to be a clinical doctor, you might want to get into dentistry and dental school as well. So you might be seeing a lot more of this if you do get into dental school. But with these questions at hand, it's kind of two parts. The first part is just to employ some simple chemistry, I guess, to satisfy some chemical equations. Second part is to have a keen eye for graphical detail. So we're told in the first half that the metal oxide, to make these dental cements, we have to mix a metal oxide with an acidic liquid. The equation, so we're told, that metal oxides, they contain divalent ions. That can be calcium, magnesium, zinc, or trivalent ions. Such as aluminium. So the acidic liquid contains divalent anions or trivalent anions. So what it just means, it just gives you an example of what di and trivalent means. So at the top, for example, the ion or the cation or the anion is going to be either 2 plus for divalent, or 3 plus, 3 minus for trivalent. So keep that in mind. It gives us an example of mixing a divalent metal ion with a divalent anion, and it gives you that equation. So if we just write it quickly, I'll write M plus A. So they've shown pretty much in the equation that they've provided in the stimulus, it just goes like this: Ma plus water. So you know from simple chemistry, when we're going to be joining two ions together like this, what happens is we crisscross, right? So this side's going to get 2, this side's going to get 2. So it's going to be 2, 2, and we know that we can just simplify it as Ma. So that's one thing to note. So keep that in mind. When we look at the figure, so the second half of this question, we have to analyze. Remember, when we analyze figures, I've said it beforehand, I'm going to keep saying it again. Look at the y-axis, look at the x-axis, understand what it's telling us for the x-axis, and understand the trends. We can see in the figure, it tells us that it shows the percentage by mass of evaporable and non-evaporable water in 4 dental cements. So you've got your zinc phosphate, zinc polycarboxylate, glass ionomer, and silicate at various times after mixing, and the compressive strengths of each. So the hydration, what we're told is that the hydration equals non-evaporable divided by evaporable water. That's important to know. And you know straight away, if we're going to increase non-evaporable, we're going to increase our hydration. So you can see in the graph, so you've got the clear bar graph and the patterned, let's say, leopard spots. You can see that the non-evaporable, it's the clear pattern. So if that is going to increase, the higher that is, the greater the hydration. If you compare it to evaporable water, which is, say, the leopard spots. So keep that in mind. Also keep in mind, we see as time goes on, we see that that white bar graph is increasing, which means we're going to have a more hydrated cement. And we also see that as the more hydrated cement increases, the compressive strength increases. So keep that in mind. So when you look at this graph, all the different possible trends and what the units are telling us. So let's take a look now at question 64. I might leave this up actually. So question 64 says, which of the following represents the formula for a dental cement formed by reacting a trivalent metal? So it's going to be a trivalent metal plus a divalent anion. So remember what we did here, the crisscross. So crisscross 2, 2. So in this instance, if we've got Ma, it's going to be 3, 2. So the crisscross. So you know straight away, simple chemistry, the answer has to be M2A3. So if we take a look at the options provided, 64 has to be A. That's easy. If you're finding that hard to comprehend, I do suggest you go back to foundations of chemistry just to understand why we do this crisscross method for the ions when we're making a bond between the two to make, I guess, a compound. So that's 64. If we take a look now at 65, it says, which of the following is true based on the information given? Okay, so let's look at 65. Let me just crisscross this off. Where are we? Our toolbar. I'll leave them both up. Actually, I'll just get rid of you guys here. I'll get rid of all of it actually. So it says, the weakest cement is the most hydrated. Is that true? Well, we know that the weakest cement will be the least hydrated because we can see that as our hydration increases, if you take a look at the graph, the compressive strength increases. So therefore, A is going to be incorrect. B says the hydration of cements increases with age. That's true because you can see with all the four groups we've provided, the four, I guess, cements, we see that as time increases, the white non-evaporable bit, so this bit, keeps increasing with time for each group. So the four dental cements. So therefore the answer for B has to be correct. But let's just show why the others are incorrect. So C says zinc cements are more hydrated than glass ionomers. So zinc cements, glass ionomer. So it's both zinc cements. And the answer is going to be no. So you can see clearly that the zinc cements are not more hydrated than the glass ionomers because you can see that the actual, it's probably easier just to focus on one time point. Let's look at 340 hours for say zinc phosphate and glass ionomer. You can see that the ratio for hydration is a lot higher for glass ionomer. And if you take a look at the zinc polycarboxylate, you can see that that's obviously a lot less. So, and the trend is similar for all the different time points. So that's why C is incorrect. D says, as hydration increases, the compressive strength decreases. No, as we established, as hydration increases, compressive strength should increase. So that's why the answer is B. Now, for this question, it was in two parts. You had to have some knowledge in, I guess, satisfying chemical equations and also just how to read graphs and have a keen eye for the trends. If you're still having difficulty with this unit, if you have any further inquiries, you can post them in the comment section below or you can contact us directly. We'd love to help. Thanks for your time. Bye now.